Percent purity. Chemicals can be impure. Only the amount that is pure participates in the reaction. Percent purity can be calculated by dividing the mass of the pure chemical by the mass of the impure chemical and multiplying by 100%. Let's look at an example. If a 1 gram sample contains 0.6 grams of pure iron, what is the percent purity? So percent purity will be equal to the mass of pure chemical divided by the mass of impure chemical times 100%. Each of those figures has 3 sig figs, so our answer gets 3 sig figs. 60.0% would be our percent purity of iron. Let's do a slightly harder example. If we react 5.0 grams of sodium, which is 90% pure, how many moles of H2 can we produce? So here's the balanced equation. And what it's saying is if we start with 5 grams of sodium, and that sodium is 90% pure, how many moles of H2 could be produced? So to be able to do this mass mole Stowe calculation, we need to know what our mass of pure sodium is, the amount that will actually participate in the reaction. So to do this, we need to find the mass of pure sodium. We're starting with 5 grams of sodium that is 90% pure. So to find the pure sodium, you can do this calculation a couple of different ways. One, you can substitute the percent purity and the mass of impure into the percent purity formula and rearrange to solve for the amount that's pure. Or if you recognize that we have a 5 gram sample and it is 90% pure, we can just find 90% of 5 grams. So 0.90 times 5 grams means that we have 4.5 grams of pure sodium. Do whichever calculation you prefer, just show me some work, please. Okay, once we have the mass of pure sodium, we can do a mass mole Stowe calculation to figure out the moles of H2 produced. We get 2 sig figs, so we have 0.98 moles of H2. Let's look at another example. If Fe3O4 is 70% pure, what mass of impure ore is required to produce 7.5 moles of Fe? Here's the balanced equation. Fe3O4 is the magnetite ore, that impure ore, and we're reacting it with hydrogen gas to produce iron and H2O. So, the question is telling us that our Fe3O4 is 70% pure and asking us what mass of that we need to produce 7.5 moles of Fe. So the first step is to find the pure Fe3O4 required to make 7.5 moles of Fe. So we do that calculation using the mole ratio and the molar mass of Fe3O4, and we find that we need 580 grams of pure Fe3O4. But ours isn't pure, it's only 70% pure, so that means we're going to need more of it in order to have enough to produce the amount of iron that we need. So to find the impure Fe3O4 that we need, we can use the calculation, the percent purity equals pure divided by impure times 100%. We know the percent purity is 70%. We know the mass of pure that it requires, so we can substitute these values in and solve for the impure. Remember, when you're doing these calculations that have more than one step, you need to write the rounded number, but actually use the unrounded numbers in your calculations to avoid round-off error. So in this case, I've written 5.8 times 10 to the power of 2 grams, but I'm actually going to use 578.5, the unrounded number from my previous calculation. So when I rearrange this and solve for the impure, I get 8.3 times 10 to the power of 2 grams of impure Fe3O4. So that's the amount that would be required to produce the moles of iron that it needs. Here's one for you to try. Please pause the video, try the problem, and then resume to check your answer. Note that this is for the same reaction as the previous example, so you can use the same balanced equation.